start our first lecture of this semester talking about addition. Going back to the basics, trying to prep and get ready for some college math here. If you don't know your basics, you're never going to be able to do your more advanced math. So starting straight with addition, one of the first things you learn to do, make sure we got all the properties in order. We're going to start out with what we call the commutative property. Basically saying that A plus B is the same thing as B plus A. The order doesn't matter with addition, as long as it's strictly just addition. So, addition is what we call commutative, meaning that one can change the order of the terms in a sum, but still get the same results. Symbolically, if A and B are any two numbers, then A plus B equals B plus A. And the fact that addition is commutative is known as the commutative law of addition, or the commutative property of addition. Okay, so we know this. If we take two random numbers, let's just say 3 and 8, 3 plus 8 is going to give you the same result as 8 plus 3. Right? Because 3 plus 8 is 11, and 8 plus 3 is also 11. The order there does not matter, and that is the commutative property. Now let's look at the associative property of addition. The associative property of addition is simply A plus B, parentheses, plus C, is the same thing as A plus, parentheses, B plus C. So basically, the order in which we add these three terms does not matter. So addition is also associative, which means that when three or more numbers are added together, the order of operations does not change the result. Okay? So, if we use a real world example here, if we said, parentheses, 2 plus 5 plus 9, and then we did the same order here, 2 plus 5, but then we put the parentheses around the 5 plus 9, it's not all going to change the results, because 2 plus 5 is going to give us 7, and then we'll add that to 9. And then 7 plus 9 is going to give us 16. If we were to do it on this side, we would have 2 plus, now the 5 plus 9 will add together to give us a 14. And 2 plus 14 gives us 16. So the order of the addition did not matter, and that is the associative property of addition. The other property we need to look at here is the additive identity. Okay, so we have A plus 0 equals 0 plus A. Essentially, 0 is your additive identity. We can add it to anything, and we keep the same result, right? Because if we choose any number, let's say 7, and I add 0 to 7, doesn't matter if I add it first or second, but basically 7 plus 0, or 0 plus 7, is still going to give us our original identity here of 7. And it's that's simple. Now, I have the worksheet here. Let's see if we can go through some of these questions and make sure we can illustrate these results and connect these properties. So the first one says, which property of addition does 2 plus 0 equal 2 illustrate? This is one that we just went over. Okay, so like I said, one we just went over should be the identity property, right? That 0 identity property right there. Okay, try to pause and give you a little second to answer these, but you can pause the video as well. Number 2 says, which is an example of the associative property of addition? Now, if we look at these, okay, we're looking at the associative property, right? If we look at A is 3 plus 6 equals 6 plus 3, okay? If we scroll down and we look at our notes here that we just took, that kind of looks more like a commutative property, right? So, part A kind of looks like the commutative property. If I look at B, 4 plus 0 equals 4, that kind of looks like the identity property, right? And if I look at D is 7 plus negative 7 equals 0, that might even look like some kind of renderation of the identity property, or some kind of something. We didn't even go over that one quite yet. But if I look at C, I'm looking at 6 plus 8 plus 5 equals 6 plus 8 plus 5. The only difference here is the parentheses are in different locations. It's associating it differently, but still getting the same result. Therefore, the answer to number 2 should be C. the associative property of addition. Now, number 3 says, which property is represented by the following statement? If A equals B, then A plus C equals B plus C. Now, we didn't go over this property. Let's think about it. If A and B are equal, then they're basically the same thing. Okay? So that means that I could, if A and B are equal, I could say and replace this A with a B. And that would mean B plus C is equal to B plus C. Transitive, no. Symmetric, no. Reflective, no. All we're really looking at here is the property of equality for addition. Basically, if you've got something, it's going to be equal to itself. Here, because these two are the same, this renders the same exact statement here. 3 is always going to equal 3. 5 is always going to equal 5. B plus C is always going to equal B plus C. If A is equal to B, then A plus C is always going to equal B plus C, because A and B are the same thing. It's the property of equality. Okay? If something's equal, you can't make it unequal. If it's equal, it's equal. Which property, number 4, which property is represented by the following statement? Okay? It says if A equals B, then A minus C equals B minus C. This looks very similar to what we did in number 3. The only difference here is we're subtracting. Addition and subtraction work hand in hand. Almost like opposites of each other, right? You add something, you increase the value, typically. You subtract something, you decrease the value. But essentially, you're just moving up and down on that number line. So here it holds that it's basically the same property as 3, but it's for subtraction, not addition. Okay? We have a property of equality for subtraction, because if it holds with addition, it's going to hold with the subtraction as well. Okay? Subtraction, like I said, works hand in hand with addition. You can almost think of it as the same exact thing, just like you can almost think of multiplication as the same thing as division. Okay? Well, we'll get to that in the next lecture. Let's look at number 5. Which equation shows the addition property of 0? Okay. The addition property of 0. Well, it's not going to be A, because A has a multiplication going on there. Okay. B looks more like a distributive property going on, and D kind of looks maybe associative. The addition property of 0 is simply C. If I add 0 to anything, it renders the same result. Let's look at number 6. Which property of addition is used in the following? Okay. It says 3 plus 2 in parentheses plus 4 equals 3 plus parentheses 2 plus 4. Did I just say this one? That's your associative property. Right? That is your associative property of addition. Right there. Doesn't matter how you associate it. Because it's addition, it doesn't matter even the order you add it in. It's all going to give you the same thing. All going to give you the same thing. Let's look at number 7. Which operation will not change the value of any non-zero number? Okay. Which operation will not change the value of any non-zero number? Well, if I add 1, it's going to change the value, right? If I have no money and I add 1 to it, now I have $1. That changed the value. If I divide by 0, that's definitely something we don't want to do. So we're going to avoid that altogether. If I multiply by 0, if I had $100 and I multiplied it by 0, technically I have $0, right? The only way I can not change the value is by adding 0. If I have $100 and I add 0 to it, I still just have $100. So, which operation will not change the value of any non-zero number? Adding 0. Just some properties of addition, you know. They play to subtraction as well. Which of the following is an example of the commutative property of addition? Now, if I look at it, it says that for part A, 2 plus 8 in parentheses plus 3 equals 2 plus parentheses 8 plus 3. I think that's the associative property, right? We just went over that in number 6. B B says 5 times 1 is 5. That's a multiplication. We're talking about addition here. Or if I look at this part C, it says 7 plus 6 equals 4 plus 7. That ain't even right, because that's not even a true statement. But if I look at D, D says 9 plus 2 equals 2 plus 9. That is your commutative property of addition. We're getting good at identifying these now, right? Got to make sure you can do what they say you can do and know what you're doing. Number 9. Number 9 says, which of the following does not show the commutative property of addition? Oof. Now, it gets a little more difficult here because now it's throwing in x's and y's. But don't let that intimidate you. If I refer back to 8, to what the commutative property of addition is, it just basically means the addition order here can change and we still render the same result. Okay? To be honest with you, I mean, if you look at it, C and D look almost exactly like D and number 8. So we know that C and D are going to check out with this commutative property of addition. If I look at part A here, the only thing that changed in part A is the order. 3x plus 4y equals 4y plus 3x. Got some addition going on here to show the commutative property of addition. The only thing that changed with the order, don't let the x's and y's freak you out. This checks out with the commutative property of addition. The only one that doesn't show, and straight out show, the commutative property of addition is a times b equals b times a. Probably the commutative property of multiplication going on right there, not addition. Man, not bad, not bad. We're doing well. Only 2 more left to go. Which equation shows the additive inverse of a number? Okay, which equation shows the additive inverse of a number? Additive inverse. Additive inverse. Now, I don't think we've covered this one. But what do we think when we invert something? Okay, kind of invert and flip it around, right? If I look at A, okay, A is the identity property. A plus 0 equals A, right? That's the identity property, not the additive inverse. But maybe you could get it to the additive inverse. It's obviously not C, because C has a multiplication going on. And then A plus A equals 2A, and we're not really inverting anything there. The only inversion happens here in D. The additive inverse of something is the opposite of it. The opposite of 1 is negative 1. The opposite of 3 is negative 3. Because we add those two numbers together, they wind up adding to be 0. That is what an additive inverse is. And you can get the additive inverse from your identity here. Okay? So, all you would have to do is switch your locations. So if I took the additive identity here from part A, if I subtracted A over, then I would get A minus A equals 0, which gives me that additive inverse. They just wrote it a little different because they said plus negative A, which is essentially the same thing. Additive inverses. Now, which is an example of the identity property of addition? Just spoke on this. The identity property of addition is shown here in part D with that addition of 0 rendering that same result. I can add 0 to anything and get my identity right back. Okay. Now, a few more things. Now, when you enter a college algebra class, at least at the University of South Carolina, Aiken, you will be very much allowed to use the TI-84 calculator. So relative addition is going to be very simple. Hopefully you can do most of it in your head. So if your teacher asks you to do a simple problem like 4 plus 5 minus 6, hopefully you'd be able to work that out in your head and not have to use the calculator. You say something like 9 minus 6 equals 3, because you combine that 4 and that 5 here to give you the 9, then you subtract 6. You can do another order if you wanted to. It's fine. Hopefully, but you can work it all out, though, and you can get that 3. Not a problem, right? Excuse my terrible handwriting. My computer's acting up on me a little bit. Now it's back. All right. The biggest key that gives most students a lot of struggle in their college algebra classes is keeping up with negatives. So I'm going to hit you with a few little problems with negatives. 6 minus 3 minus a negative 9. Okay, let's see what this result would give us. Keeping track of your negatives, like I said, addition and subtraction work hand in hand. Subtraction basically the opposite of addition. Okay, addition you're adding more to it, subtraction you're taking away from it. Okay, negative 6 and negative 3. What do these two add to? Negative 6 minus 3. When you subtract two negative numbers here, you keep the negative on. Negative 6 minus 3 is negative 9. Okay. Then, you've got minus a negative 9. Keep in mind that when you have minus a negative, it turns into a positive. So here I'm looking at negative 9 plus 9, which would give me a 0. Okay. Got to know a few things. Anytime you see a minus a negative, it's going to turn to a positive. Minus a negative turns to a positive, right? Negative minus negative stays negative, but minus a negative turns positive. Oof, hope it didn't blow your mind there. Alright, let's look at another one. Okay, if I ask you to do, let's do another problem. Let's do a 7 plus negative 6 minus 4. How about this one? Now I have plus a negative. Okay, 7 plus negative 6. Does this positive do anything to that negative? It doesn't at all. You could simply simplify this down to 7 minus 6 minus 4. Okay? And then I can simplify that down. 7 minus 6 is 1 minus 4. 1 minus 4 is going to give me a negative 3. Okay? So just because you have a plus and negative, it doesn't change. Minus and negative changes to a positive, but plus and negative just stays negative. Okay? Just a few properties that I see, or a few examples that I see students mess up at. Okay? And it could get more complicated. Like I said, the calculator is not going to save you everywhere, and that's the biggest thing that I'm kind of trying to throw at you here is some examples where, I mean, you could type this into the calculator, render as a result, but we're hoping that you can do a good bit of this by hand, because it will get more complicated in the class, where it might look something like this. Negative 5x plus 6x minus a negative 3x plus negative 2x plus 3. Okay? Now, we combine the like terms here. All these terms are like terms except for this 3 here. And we'll get more into variable stuff as we continue, but I just want to throw you a hard one to kind of end the lecture on. But I can combine all 4 of these first results. I just have to know how my negatives play out. I'm going to work left to right, okay, because all we have here is addition and subtraction. We don't have actually any multiplication that we're having to worry about in this statement. So working left to right, negative 5 plus, or negative 5x plus 6x is going to give me 1x. Then I'm just going to rewrite what's left. Minus negative 3x plus negative 2x plus 3. Now I'm going to continue working from left to right. Now I have 1x minus a negative 3x. And then, of course, plus the negative 2x plus the 3. But this minus a negative here, we know that a minus a negative should turn into a positive. Okay? So I'm going to update that. I'm going to say, okay, this is the same thing as 1x plus 3x plus negative 2x plus 3. Now I know that 1x plus 3x is 4x, and I have plus negative 2x plus 3. Now, this plus a negative here could be simplified to just minus. So we have 4x minus 2x plus 3. And in our last simplification step here, 4x minus 2x is going to render us simply a 2x, because 4 minus 2 is 2. We still need to keep that plus 3. So we can see these additions and subtractions coming at us in many different directions. We just have to take it piece by piece, property by property, go through with them, simplify it out as best we can. If you can't add and subtract, you really can't go anywhere in mathematics with that. Because everything is built off of addition and subtraction. Even multiplication is built off addition and subtraction. And then we only get more complicated from there. So, if you're having trouble with addition and subtraction, and you need extra practice on that, seek out some more stuff online. Okay? I've provided some worksheets and stuff. We've gone over this. Try this on your own if you need to. Like I said, the answers are attached here at the end so you can check yourself. So take that first one all over by yourself. Make sure you know your properties, right? Trust me, throughout the rest of the semester, we're going to get hit with a lot of different examples of different types of addition, subtraction, multiplication, parentheses, exponents, variables, even how to use the calculator, certain situations, certain functions, just to try to rack your brain and make sure that you know all the ins and outs, all the small pieces. That's our whole goal with this class, put the small pieces together so that when we have to start putting the bigger pieces together in our actual college classes, that we don't forget a foundation step that's going to cause that whole problem to topple down. Because trust me, if you don't remember that minus a negative turns into a positive, and you just straight subtract it, that first foundation intermediate step, if you get it wrong, you're going to get the whole rest of everything else wrong, and you're going to wonder why, and it's going to mess up your thought process and mess up what's going on just because of a small, simple error. So we want to go ahead and practice and get those out of the way, get the rust knocked off, bring back the thought, get the foundation set so that when we go in, we've got all of our little small issues worked out and solved out so that when we get to the harder problems, we know that it's not going to be a simple mistake that brings us down. We've got all the simple stuff down. Now we can tackle the more complex problems and the more complex diagrams and workouts, whatever the problem may be. Okay. So simple lecture today, practicing on that addition properties, throwing in some subtraction properties. Next time, we'll get even more in depth. We'll continue to work through the multiplication this week, the parentheses, the exponents this week, and then go through the whole PEMDAS workout here. Make sure we can work equations in the right order based upon what we are doing, whether it be addition, subtraction, multiplication, division, parentheses, exponents, and anything in between. If y'all have any questions, need any additional material or assistance with this, please let me know. I can guide you in that direction. Other than that, I will see y'all next time.